Running your own large language models unlocks so much for everyone. Now, the most obvious thing is that you don't have to upload your data to some big tech company, but there's more than that. I believe, and I've stated this before, that you don't need the biggest, baddest model for every task. When you have the ability to run models locally, you can start automating things you do every day for just the cost of electricity. I have an email I use for signing up for things online, and it gets overrun with spam. I use local AI along with a little bit of code to go through and organize about 100,000 emails. Maybe it was more. And I have a video about that I'll link below if you want to check out more on that. My aim for this video is to walk you through setting up LM Studio so you can run your own models locally. And I also want to go into the different configurations that really will make a difference for you so you get a better experience. Let's get started with LM Studio. This is such a great tool to download and easily run local LLMs. And it even has advanced features, which we'll talk a little bit about, where you can actually run a local server to be able to connect to them. The first thing you want to do is decide what OS you're on. I'm currently running the 0.3.10 version, and this is February 2025. I've ran all three of these. I've ran the Linux, the Windows, and the Mac one. They all work great. So go ahead and download this and get it installed. Once you have this setup installed, the first thing I want you to do is pay attention to this setting down here. You can kind of see these three options. So user, power user, developer. Set it to power user. If you are a developer, you can go ahead and set it to developer. We'll have everything that we use will be fine there too. The next thing I want you to do is go to this bottom right corner right here. And I want you to click on that. Now, the things that you'll see here are model search, runtime, and hardware. We're going to first start by clicking on runtime. What I would recommend you doing is first just making sure that you have this compatible only option set. So the runtime is very important. Depending on your hardware, you will need to have certain ones installed. LM Studio is great at having these set up for you automatically, but you do need to come in and periodically update them. If you are using an AMD GPU, double check to make sure you have ROCm installed, and ideally Vulkan as well. And the reason for that is that I found some models actually will work with Vulkan, but they won't work with ROCm. And you can always fall back to the CPU one. This will be a lot slower. Now what you want to do is make sure that you have your GGUF format set to whatever your primary runtime would be. This could be CUDA, ROCm, Metal, MLX. You can actually change this to Vulkan if you want to. But make sure this is set. If you're using a CPU, this would be set to CPU. So very important to make sure this is set correctly for your hardware. And ideally, the LM Studio would have already automatically set this for you. But again, back a while ago, there's a little bit more finicky. Now, if you want to see all of them, go ahead and click this all button here. And notice the number that are here. For example, the MLX ones, those are Mac-based. The Vulkan ones, this one happens to be Linux because it says it right there. The runtimes are very important. Just periodically check to make sure it's updated. I haven't found that it does a good job of telling me when to update it. I've actually had models fail on me until I actually go in and update it. So just keep that in mind as you go forward. So the next thing we want to do is just poke into this hardware tab right here. And the goal with this is to make sure that your hardware is being detected properly. In my case, I'm running the AMD Radeon RX 7900 XTX with 24 gigabytes of VRAM. I have 64 gigabytes of RAM, and that's all being detected properly. And you can see my CPU is also being detected properly here. If for some reason your GPU isn't being detected, I have found this only happened to me one time. I had to go through and update my drivers. I had to go through and make sure my runtime was set up correctly. And then ultimately it ended up picking it up. It was just kind of finicky. So just make sure this is working. Otherwise, you won't actually get the GPU acceleration if you're running a GPU. If you're running a smaller GPU, that's totally fine too. You're going to have to run smaller models. But ideally, you are using a GPU for this. But if you're interested, You can always just run it on the CPU. It's just going to be slower. Just run smaller models at slower speeds just so you can kind of experiment with it. So you don't have to have a GPU. It's just a very nice to have thing. Now that we have all that set up, we're going to go through and close the app settings. And what we're going to do is we're going to navigate over to Discover. And in here, you can see a ton of models that are ready for you to download. And there's just a few things I want to kind of call out to you because I think these things are very important. And then we'll download our model. The very first thing is, in particular, you're just getting started. Just select Q4_K_M. That is a good middle ground model. Going to bring the size down. Performance is still going to be relatively good, but it'll be something that you most likely can run on your hardware as long as this size, in my experience, is small enough to fit in your VRAM. And I don't want to overly complicate this, but let's say your VRAM is 24 gigabytes like mine. This is just the model weight that will be loaded in. You also need to add on the context, which we'll talk about a little bit later. So I'd like to think about this as like, this is about, maybe 1/3 of your VRAM. So this particular model, I see you could probably run on a 12 gigabyte VRAM card with no problem, with a decent context window. Just a rule of thumb, I did do a full deep dive on the quantization and what all of this actually means. I'll link that below in the description, so check that out if you're interested in more of a deep dive there. So we're going to go ahead and look at this just to make sure the download size is about something that would fit into your video RAM, and then you would go ahead and download that model. So in our case, what I would like you to do is download the Gemma 2 billion parameter model. This is a teeny tiny model. No, this is a 1.71 gigabytes. I still picked the Q4K_M. You can actually click this to see all the options here. Just select the Q4K_M. You're going to see a download here. And this download will take a little bit of time. So for example, this is one that I don't have installed. So you can see I have this green download button here. And if I go ahead and click that, you'll see that it kicks off over here into this downloader. This will take a little bit depending on your internet speed, but once it's done, it'll tell you that it's done with a little prompt that pops up, a little notification. So once you're done, you can go ahead and close the model search. And I just want to kind of point you into another area because this is going to be important for you to know. If you click on this folder on the left, you see My Models. So you can see all the models that you've loaded. They actually organize it by LLMs and text embedding. You can see I've kind of downloaded maybe too many of these, but I love testing local models. And you can see a lot of mine are the Q4_K_M, but I have actually spent a lot of time testing different quantization. Now, once your model is done downloading, what you'd want to do is you want to go to this top chat icon. Click on this. Now, I have a lot of chat windows over here. You will have none to start with. So you want to click this top bar where it says select the model to load and pick the model we just downloaded. Now we're going to get into a lot of details of this. So a lot of what this video is about configuring your model. For now, the two things that I want to talk about are this GPU offload and the context length. We're going to keep the context length at 4096. This model supports 8192. If you have no GPU offload here and you can't actually change that, that most likely means that your GPU is not being detected. Otherwise, drag this all the way over to 26 out of 26 and hit load model. Let's go ahead and test it and make sure this works. You can just say, tell me a story about a funny programmer. And you can see here on mine, it's responding really, really quickly and it's working. I'm not going to read through the story, but you can see it's about 145-ish tokens per second. And the total token count here was 627. So this worked incredibly well. Now you are running a model locally on your computer with very little setup. This is working. You are able to have a local LLM running, and that is awesome. All without sending any data anywhere. All on your own hardware just for the price of electricity. There's still a lot for you to learn, which brings me to talk a little bit about the sponsor of today's video, which is Brilliant. This is a good time to stop and just thank Brilliant for sponsoring this part of the video. What I like about Brilliant is how easy they make complex topics. I bought my teenage son Brilliant so he could learn about big data, and he loved it. Not only did he gain a deeper understanding of data, he also learned enough to help me at my company with some data analysis. And what I'm really excited about is their course on Intro to Large Language Models. This is a beginner level course that teaches you how large language models work. You can learn about some of the topics we covered in this video, such as temperature and probability of next token. If you are just getting started in the world of AI, this course is perfect for you. You will finish the course with a much stronger understanding of how LLMs work, which is awesome because it will help you understand how to use them better. AI is just getting started, with the majority of people still not incorporating it into their day-to-day job. If this sounds cool to you, to try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/gosucoder or scan the QR code on screen, or you can click the link in the description. You'll get 20% off an annual premium subscription. Thank you so much, Brilliant, for sponsoring this part of the video. So the next thing that I want to talk about is this context length. This is incredibly important for you to understand. But the one thing to know is the higher that you make this, it's going to equal more memory that you need. But it also means that you would have more data that the LLM is going to know about. So to give you a little bit more understanding of this, let's pretend you have a notebook. And in this notebook, you can only put 10 lines of text. We're going to pretend that's 10 lines of text. Now, anytime that you need to put more into it, you actually have to remove a line so that you can insert a new one. You can only hold 10 lines of text. That's what the context window is. So in the case of 496, it can only ever hold 4,096 tokens. Again, the higher you make that number, the more memory it actually needs. And it is not a linear increase. It's actually more of a quadratic increase. Higher the tokens, the more memory that's needed, and actually processing as well. So this is not to scale or anything, but you kind of get the point here. The goal is you need to find the right balance for your task. So if you need more context, you're going to have more memory. Typically, if you're just doing small tasks, 4096 is fine. But there are some tasks that I have where I need 20,000 or 30,000 context. And some models actually have way more than that they support. The other point to make is not all models actually support the same amount of tokens. So some might actually support like 16K. Some might support 128K. Some might only support 4096. So you kind of need to look at the configuration of the model to determine how much context they actually have. And again, just remember that notebook analogy that I gave you. Basically, it can only fit that much into its brain. Like you're talking to it, you're telling it stuff. Eventually, it has to drop stuff so that it can understand the new stuff that you're telling it. So that is context window. So for example, here's a model called 5.4, which I actually really like this model. This thing can support a max context window of 16,384, whereas the Gemma 2 one that we just talked about can only do 8192. So you'd want to set this to something that your system can support. If I load this model into my VRAM, you'll see it go from like 7 gigabytes to 16 gigabytes at a 4096 context window. So you can see here that it's, about 8-9 gigabytes of memory that it's taking up. But if I increase this to the max context window, it uses 20 gigabytes on my computer. So you can kind of tell, like, it is a pretty drastic increase from 4096 to 16,384. So it's just something you're going to have to test with your own system and make sure that you're monitoring it properly. So the next most important thing for you to know about is temperature. Most people, myself included, ignored this when I first was getting into running these locally. But this has actually had the biggest impact for me to be able to get the best performance out of my models. For example, a lower temperature is going to mean that the model is going to be more consistent. It's going to not be as creative. So let me give you an analogy on this as well. Let's say you're a musician and you have a sheet of music and you've got your musical notes here, there, wherever it is. Now, you can, on a scale from 0, let's just say to 1, I'm simplifying this a little bit, 0, you follow this sheet absolutely perfectly. 1, you start doing just the most random things ever. Right? You're playing a bunch of different notes. You're taking some risks. And every time you play, this becomes like a very unique musical output that you're doing, where this is going to be always the sheet music. Now, this is an overly simplified version of this, but that's really what temperature is doing. It is basically being more creative in how it's picking the next word that's actually going to show up. Typically, what I like to say is higher if you want creativity. Typically, I say higher temperature will result in more creativity. Some models are very sensitive to temperature. Some it's hard to tell the difference with. So again, you have to test this. I have some models, if I set the temperature too high, I start getting random gibberish. I've got others, I set it high, and you can't really tell a difference. Because it also depends on how the model's been fine-tuned. So sometimes you need to actually read the documentation on the model to know what the ideal temperatures are. But one thing is LM Studio will always start to 0.8. And there's a model, for example, that I really, really like, which is Mistral 2501. It's their small version, 24 billion parameter. I started using this at 0.8 and I thought it was like, okay, I didn't think it was that great. I changed it to 0.1 and its coding performance went through the roof. So I would like to tell you, like, try them, do some side-by-side comparison. But also, if you want a more consistent output like code, 0.1, I've heard some people even go to 0. I haven't found much difference between 0 and 0.1. Sometimes 0.2 is also okay as well, but you want a lower temperature value. The next one I think is important is this top K sampling. It defaults to 40 typically in LM Studio. Think of a chef picking the next ingredient in a recipe. For each choice, the model would assign a probability of the likelihood that a word would come after the previous word. So top K sampling is really telling the model, or the chef in my analogy here, to only pick between the top K items, which in this case could be 5. And everything else below it would be ignored. So a more concrete example is if you have the text, the dog chased the LLM might have words like this: ball, cat, squirrel, rabbit, stick, elephant, piano. Each of these have their own probability. You can see here the likelihood that the dog chased a piano is very low. Now, if you had a top K value of equal to 3, you're going to get picked between ball and squirrel. The rest of them would be thrown out. So you can kind of see here how the creativity starts playing into this. The number of words that you limit it to kind of works in tandem with temperature. It's important to think about because you may want a very creative model with a high temperature and also a wide range of words to pick from. You can get some really interesting results if you have both a high temperature and a high top K value. So again, it just depends on the model because some models are very sensitive to this and some models are not. But I have found some very interesting results when you want something super creative when you have a high temp and a top K value. So these kind of work in tandem with each other. So the next most important one is the repeat penalty. You can kind of think about this as like a penalty if words start repeating after each other. And I've actually had models do this before, and I've had to crank up the repeat penalty to make sure repeating stopped. Okay, so you can kind of think about it like this. So the cat saw a cat. This would be something that you probably want to adjust a repeat penalty for. And remember that list of words we talked about in the top K sampling? What would happen is the value, the probability of that would actually get penalized and get brought down. So if this were cat here, that would actually get brought down to a lower ranking based on that number that you have in there. So you can actually move it out of the top choices. The repeat penalty will make your sentences sound a lot better. So you won't get the cat saw a cat very often or likely, and you'll get something more like the cat saw a mouse, which just makes more sense. Or you might say the cat walked to a cat, or the feline crept forward because now you switch from cat to feline. Or our furry friend instead of the cat. Like you can kind of start guiding the AI to start switching words out and kind of minimize the repetitiveness of the same word over and over again. You know, when you're first learning to write, you write like, the boy jumped over the ball. The boy then walked to the ball. The boy then picked up the ball. Like, that's not what you want the AI to do. You don't want it to write like a kindergartner. These are going to be the last two that I cover in this video. And if you're interested in a more deep dive on some of the other settings, let me know. There's a lot more that we could play around with, like structured output and speculative decoding. But top P sampling and min P sampling are also very important for you to know. So some models use top P nucleus sampling and min P nucleus sampling. And I want to explain what that means. So let's say P is 90% or 0.9. Instead of, in top K, where it's picking the top X items, what this is doing is it's actually trying to fill up to 90%. It'll go through and it'll add pasta. It will then add pizza, so now we're at 55%. We'll add salad, so now we're at 75%. We'll add soup, and now we're at 90%. And we'll totally ignore dessert because we're at our 90% threshold there. The top P nucleus sampling basically allows the probability filtering. So instead of filtering on the number, you actually filter up to a certain probability. So maybe you want only the top 50% probability, and you'd only grab like the top 2 here. So min-P sampling, I like to think about as the quality control. And what it does is it sets a minimum threshold for how good a choice needs to be. So in this case, let's just say it's, 30% or 0.3. What that would mean is in this case, we would need a minimum of 30% here for it to get included in the possible output characters. So we would only end up having pasta. Now, if it were 20%, we would end up with pizza, salad, and pasta there. So I know this video has gotten long, but I do think it's important to kind of put this all together. So let's think about the top K as the first bouncer. And I think this is important for you to understand when they do work together, how this actually happens. And let's say that we want to get the top 100 most probable words. So this top K would be the first thing that actually filters out the list of words. So we end up with a subset of words that is equal to 100 here. Now we may have a top P. Now top P we can think of as like our second bouncer. We're not going to let them get past the second door unless they pass another test. And we're only going to keep the ones that meet some sort of threshold of probability. So for example, we're going to start at the top and start adding all the way up. And we might filter this down to like 72 words or something a lot less, because top P cares about the overall probability, not the number that are actually in the list. And then we have our quality control, which this one, what they will do, we'll just call this our tester. It's gonna throw out any that have a low quality based on what score you have. So that may actually throw out even some of those 72, and we might end up with like 50 words that are actually possible for the next token because they don't meet that min P threshold. So if you set this too high, you can end up with not enough tokens. If you set it too low, it's not going to really do anything. So just remember, like, it's kind of like a 3-stage thing. So we've got our top K picking the top 100 words. We then have our top P, which lowers that down based on the threshold. If you have this set high, it's not going to be as aggressive here. So you actually may end up with something like only 2 getting called out. But if you set it lower, you set it to like 70%, you'll start aggressively calling that top K list there. And then we have our quality control or tester, which focuses on pulling out any that are just too low a quality that we would not want picked anywhere. It's a really interesting approach, and I think it's important in combination with temperature to understand like how all this stuff works together. Now this video only scratches the surface of what you can do with LM Studio. If there's an interest, I can make a part 2 where I go into more detail on things like running a local API, speculative decoding, and many other things that are available. I hope you found this video helpful. If you have, please let me know in the comments below and drop a like and subscribe. Until next time, everyone, peace out.